So in this video, we are going to continue our discussion with this question 8.3, which asks what is the value of trigonometric ratios at 5 specific angles. So in the previous video, we saw the specific angle as 45 degree and where we found out these 6 values of these 6 trigonometric ratios. Now in this video, we are going to take next 2 specific angles, 30 degree and 60 degree, and we are going to find out again the values of these trigonometric ratios, these 6 trigonometric ratios at these 2 angles. So first of all, I'm going to make this table ready, and we can expand more. Yes, and so this is going to be my so let me draw a line here and also a line here. Okay, so this is going to be our 30 degree column and this is going to be our 60 degree column. Now remember that when we are finding the values of these 6 trigonometric ratios, we actually need to find the values of only these 2 basic or these 2 foundational trigonometric ratios. Once these 2 values are found, then the remaining 4 values can be found out by their formulas or by the derivations, because these 4 are derived from sine and cos. Okay, so even for 30 degree and 60 degree, we're just going to find sine 30, cos 30, sine 60 and cos 60, and the rest 4 will be derived. Okay, so let's continue and let's see how we can do this. So first of all, let's start with an equilateral triangle as our consideration. So consider an equilateral triangle ABC. Okay, so let me quickly draw an equilateral triangle ABC. So this becomes my equilateral triangle ABC. Let's name it. So this is A, this is B, and this is C. Now as we know that equilateral triangle, any given equilateral triangle has 2 important properties which I'm going to note down here. Okay, so 2 properties of equilateral triangle. Property number 1 is that AB is equal to BC is equal to AC. Okay, let's mark it here. All the 3 sides of equilateral triangle are equal to each other when it comes to their length. That is the first thing. And second thing is angle A is equal to angle B is equal to angle C, which is equal to 60 degree. Again, this is another property of equilateral triangle. All the 3 angles are congruent to each other, and we know that summation of the 3 angles of any triangle is 180 degree. So each angle is going to be 180 divided by 3, which is 60 degree. So all 3 sides of an equilateral triangle are congruent to each other, and all 3 angles of equilateral triangle are also congruent to each other. Now we are going to do some construction on this equilateral triangle. So let's continue with our construction. So yes, so construction, what is the construction that we are going to do? So the construction is draw a perpendicular line from vertex C to the base of the triangle, to the base AB. Okay, so this is let's bring this. Yes, so this is our triangle, equilateral triangle ABC. Now the construction that I'm going to do is draw a perpendicular line from vertex C to the base AB. So this is how the perpendicular line is going to come, and this is going to be perpendicular here. Okay, and let's assume that this meets the base AB at point Q. Okay, so ABC is my original equilateral triangle. I'm constructing a perpendicular line which intersects AB at point Q. So okay, just a minute, let me check if okay, so we have done this construction of a perpendicular line, and this is our 90 degree. Now let us focus on, okay, now consider these 2 triangles, triangle AQC and triangle BQC. Okay, these two half triangles, triangle AQC and triangle BQC. Okay, now we are going to prove that triangle AQC is congruent to triangle BQC. How is that possible? Because, so let me in fact write it down. It's congruent to triangle BQC because angle A is equal to angle B. Okay, 60 60. Then we have angle Q as equal to angle Q. So I'm going to write here because this is 60 degree. Angle Q is equal to angle Q. This is 90 degree. And side CQ is equal to side CQ. It's a common side. Okay, it's a common side between these two triangles. So thus, by our AA test, okay, by angle side test, by angle side test, triangle AQC is congruent to triangle BQC. These two triangles are congruent to each other. That is what we have proved. Now, if the triangles are congruent to each other, we have another interesting observations to make. Let me take a different color. Yes. So let's draw a line here. Hold on. Let's draw a line here. Yes. So since these two triangles are now congruent to each other, okay, we can say that angle. Okay. So this conclusion is coming from this. Okay. This statement. Since we have triangle AQC as congruent to triangle BQC, we have two important conclusions to make. Conclusion number one is that angle ACQ is equal to angle BCQ. Okay, so basically, if you zoom in, I'm talking about this angle. ACQ is equal to angle BCQ, and since this is a 60 degree, it's going to be split into half. So we are going to get. I'm going to use the eraser now. Let's zoom in. Okay, so this goes, and thus we have two 30-degree angles. This is also 30 degree, and this is also 30 degree. Okay, why? Because angle ACQ is equal to angle BCQ. And why these two angles are equal to each other? Because these two triangles are congruent to each other. So thus this 60-degree angle gets split into two. That is the first observation. So let me make a note of it. That is my first observation. And my second observation is AQ is equal to BQ. Again, because these two triangles are congruent to each other. So this AQ is going to be equal to BQ, which is going to be equal to half of AB. Okay, it's going to be equal to half of AB. So thus we can say that. Now once again, let us try to erase the blue line. Okay, so this was, and yes, this is my 90 degree and this is my point Q. So once again, what we can say is that this AQ is equal to BQ. Okay, and thus Q is in fact the midpoint of this triangle, of this side AB. Okay, so thus CQ, which we constructed as a perpendicular line from vertex C, it has act as an angle bisector. So it's an angle bisector at angle C, and it has also become a perpendicular bisector for this side AB. And we get these two important conclusions here, that angle ACQ is equal to angle BCQ, which are now 30 degrees, and AQ is equal to BQ, which is equal to half of AB. Okay, so now what I'm going to do is I'm going to take this triangle out and copy, and in fact bring it here for our further discussions. Yes, paste. So let's reduce it in a size bit, and here it's okay. Now note that yes, so note that AB is equal to BC is equal to AC. Okay, that is because this is our equilateral triangle. Okay, so now I'm going to say let AB equal to BC equal to AC be equal to 2p. Let the length be equal to 2p, and therefore I'm going to have AQ equal to BQ, which is going to be equal to half of AB. So it will be half of 2p, and that is going to be equal to p. Okay, important point. Since AQ equal to half of AB, and I assigned AB as equal to 2p. So now AQ and BQ have become of length p. So let's mark it here. So yes, this has become of length p. This has become, so don't confuse that with a capital P. Let's zoom in. This is a small p. This is also small p, and this is 2p, and this is also 2p. So this is our triangle ABC, where the sides are of length 2p, 2p. Even AB is 2p, but AQ and BQ is p, and this angle is 30 degree, and this angle is 60 degree. So now, so this is our current state of the the current state of the triangle. Now what I'm going to do is I'm going to focus only on this triangle, the right hand side BQC. So once again, let me just create a copy of this, copy, and let's bring it down here, paste. Okay, so what I'm going to do is I'm going to take an eraser and just erase this half of the triangle. Yes, so we don't need it for our further discussions. We don't even need this A. Okay, now let's focus on this triangle, this half of the triangle, which is BQC. As you can see that this triangle is right angle triangle at point Q. Why is that so? Because we constructed a perpendicular from the vertex C. Now in this triangle, we have the side 2p and we have the length of this side p. We need to find the length of this side of the triangle. And then in this right angle triangle, we will know all the length of all the three sides of a triangle. And after that, we can go and find sine 30, cos 30, and sine 60 and cos 60. Okay, so that is the plan. So first of all, let's start with our Pythagoras theorem. Yes, so using Pythagoras theorem, we have BC square, which is our hypotenuse. Hypotenuse is always the side which is opposite to the right angle triangle. So BC square as equal to BQ square plus CQ square. Okay, but what is BC? It is 2p. So 2p the whole square is equal to BQ, which is p square plus CQ square. Okay, and therefore we get 2p the whole square is 4p square as equal to p square plus CQ square, and therefore we get, by rearranging, CQ square is equal to 3p square. Now let's take square root on both the sides of the equation. We get CQ as equal to under root of 3p. So this becomes my length of side CQ. So I'm going to come and note it down here. CQ is now under root of 3p. Okay, now have a look at this right angle triangle. In this right angle triangle, we know all the three sides of a triangle. So very happily, we are going to use this information and find out. This is the table that we want to fill up here. We want to find out sine 30, cos 30, and sine 60 and cos 60. So let's use this triangle to do so. Okay, let me make a copy of this once again so that I have space. Copy, yes, let's bring it here, paste. Okay, so now let's begin. Let us zoom in. Yes, so let's start with sine 30. So sine 30 degree. So what is the sine of an angle? Sine of an angle is the opposite side, okay, divided by the hypotenuse. So I'm going to write here opposite side BQ divided by hypotenuse, which is BC. But what is BQ? It's P. What is BC? It's 2P. P and P cancel each other. It becomes half. Similarly, let's find cos of 30 degree. Cos of 30 degree is equal to adjacent side. So for this angle, adjacent side is CQ. So I'm going to write here CQ divided by hypotenuse. Hypotenuse is the side opposite to the right angle triangle. So it's BC. And what is CQ? CQ is under root of 3p. The whole divided by BC is 2p. And that is equal to root 3 by 2. Thus, we have successfully found out sine 30 and cos 30 from this triangle. Now let's go up and substitute these values, half and 3 by 2. So here we come. Okay, so this is going to be, let's use the green color. So sine 30 is half and cos 30 is root 3 divided by 2. Now in order to reduce the confusion, let me just cover up this box because there are too many numbers. Yes, okay, that's perfect. Okay, so now we have sine 30 degree as half and cos 30 degree as root 3 by 2. We can easily find the values of these four trigonometric ratios. Let's do it quickly. Tan 30 is sine 30 divided by cos 30, sine 30 divided by cos 30. So that is going to be 1 by root 3. Okay, these two denominators 2 will cancel each other. Now sec 30, sec 30 is going to be uh, yes, sec 30 is going to be reciprocal of cos. Sec 30 is equal to 1 upon cos 30. So we just want to find the reciprocal of this. That is going to be 2 by root 3. Okay. Then we have cosec. Cosec is the reciprocal of sine. I always get confused between which is the reciprocal of which. So the easy way to remember is cosec and cos. They don't go with each other because they have same initials. So they do not go with each other. So for cosec it's sine and for sec it's cos. That's one way to remember it, or that's how I remember it. So cosec 30 is nothing but 1 upon sine 30, which is reciprocal of half. So that's going to be 2. And cot 30 is the reciprocal of tan 30. Tan 30 is 1 by root 3. This is going to be root 3. Thus, for the specific angle 30 degree, we have found out all the 6 trigonometric ratios. Now let's continue with 60 degree. Again, let's go back to that angle, sorry, that triangle that we have. Yes, this is the triangle. Let's zoom in. Okay. So now we want to focus on this angle of 60 degree and find sine of 60 and cos of 60. So let's do it. Okay. So sine 60 degree, again sine 60 is going to be opposite side, which is CQ, divided by hypotenuse, which is BC. So opposite side of 60 degree is CQ divided by BC. And what is CQ? That is root 3 of P. The whole divided by BC is 2P, and thus that is equal to root 3 by 2. And now let's find cos of 60 degree. Cos of 60 degree is adjacent side, which is BQ, adjacent to 60 degree, divided by hypotenuse, which is BC, but BQ is P and BC is 2P. So that is going to be equal to half. So as you can note that sine 30, which is half, is equal to cos 60, which is also half, and cos 30, which is root 3 by 2, is equal to sine 60, which is root 3 by 2. So the values have got swapped with each other. Now let's go to our table and substitute these values. Yes. So let me make this substitution. So sine 60 is root 3 by 2 and cos 60 is half. Okay, reciprocals. Now again quickly let's find out these four trigonometric ratios which are derived from sine and cos. Tan is division of sine 60 and cos 60, so that's going to be root 3 divided by 1, so it's just going to be root 3. And then we have sec 30, sorry, sec 60. Sec 60 is reciprocal of cos, so reciprocal of half is going to be 2. Then cosec is reciprocal of sine, so that's going to be 2 by root 3. And cot is a reciprocal of tan, that is going to be 1 by root 3. So thus we have found out all the values of 60 degree, all the 6 trigonometric ratios for specific angle 60 degree as well as specific angle 30 degree. So let's come back to our original question. Yes, the original problem statement or the original discussion was for this specific angle 30 degree and 60 degree, what is the value of all the trigonometric ratios? So these are the values of all the trigonometric ratios. So once to quickly revise what happened in this overall video, we started with an equilateral triangle ABC where all the 3 angles are 60 degree and all the 3 sides are congruent to each other. Then we did this construction. This is an important part in the entire video. We did this construction of drawing a line CQ perpendicular, very important, 90 degree to AB. And then after doing so, we proved that these two triangles, these two half triangles are congruent to each other by using a AAS test. And once we prove that these triangles are congruent to each other, this is the two observations from that. One is these two angles are equal to each other, so they each become of 30 degree now. And second is that AQ is equal to BQ, which is half of AB. So Q becomes the midpoint of this side AB. And thus we came to this conclusion that these two angles are 30 degree each, and these two sides are equal to each other, so P and P. So we assumed that let the equilateral triangle sides be equal to 2P. So this became P, this became P, and this is 2P and this is 2P. Then we ignored this left hand side half triangle and we focused on this right hand side. So we came to this right hand side triangle where we knew this is P and this is 2P. So we wanted to find out what is the length of CQ. So since this is a right angle triangle, by construction we used Pythagoras theorem and we found out CQ is equal to under root 3P. And now once we know all the sides of a triangle, we can find sine 30 cos 30, sine 60 cos 60 from this triangle. And all these values of sine and cos we substituted in this table. Here it is. And once we know the values of sine and cos, these four can be derived from sine and cos values. So this is the quick summary of how to find values of all trigonometric ratios in this specific angle 30 and 60 degree.